So this topic I've called centripetal forces, but really what we're going to be looking at here are force problems involving circular motion and where there are forces that somehow have to explain the centripetal acceleration that an object has when it is in uniform circular motion. And the first formula I have there is F net is equal to mv squared over r, but recognize that really is just Newton's second law. F net is equal to ma, but where I've replaced the acceleration with the formula for centripetal acceleration. In other words, we're going to be looking at problems where we expect that to happen for one reason or another. In general, I think when I do those problems, I'm just going to still write F equals ma to begin with and make sure I understand and can argue correctly why this is the correct thing to do. So in that sense, I mean, whether like if I were doing this and wanted to write something in my notes, would I write this? I'm not sure if I would, because to me, this is the concept. F equals ma, and then that's combined with the concept centripetal acceleration is equal to v squared over r. It says here on the key concept slide that there is no specific type of force associated with circular motion, but the net force must be centripetal. In other words, the net force must somehow explain how this centripetal acceleration is happening, therefore it must point in that, what centripetal means is that direction, towards the center. Now, I'm saying that because I want to kind of combat the intuitive notion that is out there that if something is in circular motion, there must be some kind of centrifugal force associated with that. That's something you might have that as an intuition, right? Centrifugal force is associated with being moved in a circle, right? Maybe if you're on a roller coaster, you can say, I'm experiencing centrifugal force, but are you really? It turns out centrifugal force is not really a force, but it's a pseudo force, and I think we might see that come up in an example at some point, but there really is no force type that is centrifugal. Centrifugal just is another description of direction, and in that sense, if somebody said, hey, there's a centripetal force here, I'd say, okay, but what type of? Because given different situations, it could be a tension force, it could be a normal force, it could be a friction force, it could be maybe traction force would be the same as friction force, could even be a gravitational force. All of those can be centripetal for different kinds of situations involving circular motion. So in that sense, if I say, is that really a type of force? Can I identify it with a type of interaction that two bodies have when one is pulling on the other or pushing on the other? And the answer is no. Both centripetal and centrifugal don't have that meaning in physics at all. Both of them merely describe direction, and really in circular motion, the direction of acceleration is centripetal. So that's the main concept that I'm focusing on.